My name is Andy Taylor, and I work for Congressman Michael McCaul. Thank you all for coming to today's briefing. Congressman McCaul and Congressman Mousses are going to be running a little bit late, so hopefully we'll have them here soon. Just in the interest of time, we're just going to kind of kick things off so that we can get the conversation started. For those of you that don't know, Congressman McCaul is the co-founder and co-chair of both the high-tech caucus and the childhood cancer caucus. He works with Congresswoman Mousses on high-tech and Congressman Van Hollen from Maryland on childhood cancer issues. And so when we heard that Dell and TGen were teaming up to do some work using cloud technology to help better understand a very rare and aggressive form of childhood cancer called neuroblastoma, this issue seemed to be kind of really right up my boss's alley. Crosses over two issues he works on a lot. It also happens that Dell is located just barely outside of my boss's district in Austin, and so we have a lot of constituents who work for Dell. We're very proud of the work they're doing. We're going to let Nancy Goodman kick us off here today. Nancy Goodman is the Executive Director of Kids vs. Cancer, and she's going to be talking a little bit about what this is like from a patient perspective.
And thank you, the high-tech caucus and the childhood cancer caucus for inviting me here to speak. I'm the Executive Director of Kids vs. Cancer. And how did I get there? I got there because my son, Jacob, my oldest child, was diagnosed with brain cancer 5 years ago. Ding! This is Jacob. And here's our photo. Jacob was 8.5 years old when he was diagnosed. He had absolutely no symptoms that seemed unusual to me, but they were in fact symptoms that were immediately obvious to a neuro-oncologist. So one day Jacob was a healthy kid. The next day he had emergency brain surgery, and he never recovered really. He was wheelchair bound, he had difficulty speaking, he was anorexic, he had minimal control over all of his bodily functions. Cancer, pediatric cancer is just a terrible, terrible illness. And how devastating is it to lose a child? You lose your child every single day. You lose your child. Yesterday was what would have been Jacob's moving up day for 8th grade, and all his friends at school were there, and Jacob wasn't there. He got to hear speeches instead. So that's what you lose as a parent. And I think that's what we as a society, I think we guard against is really one of the greatest losses that we could ever not imagine. So on the next page is, what my family is like now in our last Christmas picture. Jacob is just a photograph. He died when he was 10 years old. And why did he die? He died because we just haven't done enough to figure out what kind of drugs effectively treat kids with cancer. In fact, in the last 20 years, the FDA has only had an initial approval of one pediatric cancer drug. I think this is really a disappointing and unacceptable statistic for our community. I think we need a multi-pronged approach to address this serious challenge. In Forming Kids vs. Cancer, I've been working with Congressman McCaul and with Andy Taylor and Congressman Butterfield and Van Hollen on creating HOPE Act, which I'm thrilled to say the House included in the GIFA bill that the House just voted on, and we hope it will be in the final FDA authorization bill. The Creating HOPE Act provides financial incentives for pediatric drug development for new drugs. But what else can be done? And one other approach that I think is very important to discuss right here today is the personalized medicine approach, which Dell and TGen are focusing on, and we from the pediatric cancer community are so appreciative of that. What does that mean as a parent? When Jacob was diagnosed, we learned right away that Jacob's disease was refractory to treatment, which meant that it was not responding to the chemotherapies he was receiving. Jacob followed a trial, which is what most kids with cancer, how they're treated. And our immediate question to our oncologist was, does Jacob really fit the population that is the target population of this trial? It's kids with a certain diagnosis and certain other parameters. We said, is there a subpopulation of kids like Jacob who just aren't responding to treatment, and is he going to be one of the kids who survives or not? And our oncologist couldn't answer the question, and the primary investigator of the trial couldn't answer the question. And the answer was no. The answer was What we now know, we didn't know 5 years ago, is that there are many subtypes of medulloblastoma and Jacob's disease, and these kids with different subtypes have different genetic profiles, and they respond differently to chemotherapy. And Jacob's subtype does not respond to this form of chemotherapy, and it was a waste. It was a waste because we had not done enough research in time to save my child. And so that's why I think a personalized approach for a kid like Jacob, who is refractory to treatment, really might result in saving lives, and that's so important. Why else is personalized medicine really appropriate for pediatric cancer as opposed to other indications? Standing up here telling you my story, I think the need is so great, and what we've done is so minimal that it's really where we should start. But I want to bring up a couple other reasons why pediatric cancer is where we should focus our attention for personalized strategies, personalized medicine strategies. First of all, parents of children with cancer are desperate. We will do absolutely anything. And we are more tolerant to risks of toxicities or of just unknown outcomes than perhaps any other patient group. We know our kids may not survive. And really, we understand the risks. We are educated. You would be amazed how educated even uneducated parents are. They get very bright, and they have the capacity to understand the risks. Second of all, as our following speakers will tell you, there are a lot of issues around privacy when we put together personalized medicine trials. We're creating databases which will inform medical research going forward. Parents of kids with cancer do not care about privacy. We don't care if all of you know my entire genetic history, my husband's genetic history. In fact, we donated Jacob's tissue to researchers. Mike and I provided blood samples. We waived all privacy rights. We just don't care. And our friends, they don't care either. Nobody cares about privacy. HIPAA and the IRB regulations, which are intended to protect families from infringements on privacy, are not a good match in the pediatric cancer space. What do I hope for in the future? I hope this project with TGen and with Dell expands so that it serves not only kids with neuroblastoma, but all kids with cancer. There is so much need out there, and if we could get the funding and if we could build out the program, it would have such wonderful, potentially wonderful, great effect for so many needy children. And I hope the program expands not only to matching kids with approved drugs, but with unapproved drugs. And I believe that there's an opportunity to do that. I believe the FDA is open to working with teams such as this to give kids with terminal cancer every shot they can at surviving. Thank you very much.
Okay, well, my name is Spyro. I'm a scientist at the Translational Genomics Research Institute, and it will be my pleasure today to tell you about our really innovative project. Oh, just in time.
That was a good time.
Thanks. Easy. Well, thanks.
My hero, by the way.
I apologize. I serve on the ethics committee, which doesn't make you a popular member of Congress, but I was tied up in a meeting. So, but I'm proud to kick off this joint childhood cancer caucus and high-tech caucus event. I want to thank Dell and TGen for being here. In fact, I'm very proud that a lot of Dell's employees are in my district, and Michael Dell's not too far down the road, and I see there's a Dell lobbyist that just walked in. But I just want to kind of give a shout out to what Dell has done for childhood cancer in terms of donating the cloud computing space to TGen, which is basically a genome project to combat neuroblastoma, which is, as many of you know, with children is a very, it's lethal in almost every case. It's a very life-threatening condition that kills so many of our kids out there. And so I want to thank Dell, not only for the donation of cloud computing, but the financial donations that you made, millions of dollars towards research and development in childhood cancer. I don't know, have you spoken already?
I have.
You have, okay. And Nancy may have told you about the Creating Hope Act passage. overwhelmingly in the House. This is the first childhood cancer drug bill that we have had passed in the history of Congress. And I believe it's very significant. I can't take the credit. Nancy is the author, I always say, and I was the vehicle who helped get it through. You would think something like this would be a very easy thing to get passed, but it was not. We had a lot of roadblocks and obstacles. Pulled in Nancy to help out. My wife was kind of the secret weapon. She works on the board. MD Anderson chairs the Childhood Cancer Committee. And we pulled Brianna, who's a 14-year-old cancer survivor, the national spokeswoman, I guess, or girl, if you will. Phenomenal spirit, and actually had her file the bill. She lobbied members of Congress on the floor. It was just a tremendous thing to see, and it was hard for members to say no to her. And so we had about 180 co-sponsors at the end of the day. We finally convinced Mr. Waxman it was a good idea. He, in the end, supported the bill, and it's on its way to the Senate. And all the conversations I've had with the Senate, it looks very positive. We're going to get it to the President's desk by, hopefully before the August recess. So I know that's not what this is. This is more about TGen and cloud computing and what Dell's doing. But I thought it was kind of a nice marriage between, high tech and the childhood cancer issue, and how you can use technology to defeat the #1 killer of children in this country. And so, with that, thanks to everybody for being here, particularly Nancy. And I'll turn it over to our panelists. Thanks. Your mic.
Okay, so again, we're here to represent just a phenomenal project. It's being supported by Dell, as you heard, and we're going to start off by showing you a little video to introduce the incentives behind the project. You heard from Nancy how important this is. We wanted to talk a little bit about the incentive and then go into a little bit of the details of what the project is and how cloud computing is going to hopefully revolutionize what we're doing for pediatric cancer.
Neuroblastoma is a pediatric cancer. It's a cancer seen in kids, generally less than 6 years of age, and it's a tumor of the nervous system.
This cancer, only a handful, a fraction, a few percent can be cured.
Today, we use chemotherapy that attacks the whole body. About 50% of those kids are going to relapse, and when they do relapse, there's no cure.
Every neuroblastoma is a little bit different, and what you want to be able to do is use high-performance computing and new areas like genomics to really target the treatment to the patient.
TGen is really focused on trying to bring medical advances from the Human Genome Project into medical benefit for patients with a series of diseases and disorders. It took us 10 years and almost $3 billion to sequence the first genome. It now takes us only 10 days and only a few $1,000s to sequence a genome.
The amount of data that's being generated in each of these tests is around 30 terabytes for a patient.
What you're asking people to do analytically is basically take subjects like a law library, shredding it, totally shredding it, and then putting it back together.
There's so much data coming at them. We want to be able to help them bridge this gap and be able to use data most effectively to be able to bring the best kind of treatment for the patient.
A patient can't wait 2 months for a treatment regimen, especially with children with neuroblastoma. The disease grows very quickly.
Dell's technology is going to make an incredible impact on the ability of TGen to speed up the time it takes now between diagnosis and the correct treatment that they're finding. Today it's several months. Our technology will speed that up down to days.
What we're building is a cloud that allows us to be able to store all this data in a shared environment and then have all the scientists get access to anything we want to.
It allows us to incorporate this remarkable new technology. It really works on the back of computer systems like Dell's in order to really make a difference for the patients.
We bring a huge amount of expertise in genomics and proteomics and in high-performance computing. So we really bring leading-edge techniques that really change the way that this genomics research is done.
I think by doing this sequencing, you're going to find the Achilles heels of many of these childhood cancers.
The lessons learned from this type of a project will be exceedingly useful for many of the common cancers that so many
definitely the future of medicine. It becomes the model for how you do cancer research moving forward.
Adding a birthday, adding an anniversary, adding other aspects, those single steps are so powerful.
Success in this effort is helping the person who's sitting in front of us right now.
I can't wait to share with the Dell family where we've made a difference for these kids with cancer.
Okay. So with that introduction, let me now start to talk a little bit about the science. And again, I'm here representing the science at TGen. The work that I'll present is a real team effort. So there's a tremendous number of people involved on the clinical side, the genome generation of data, the interpretation of data, and the newest arsenal in the battle against pediatric cancer is Dell with the compute infrastructure that you'll see that has really accelerated this process and the ability to communicate and create collaboration clouds. So let's start with this slide. So first of all, let's talk about the old model of how patients are treated today. We call it evidence-based medicine. Evidence-based medicine essentially says that if you have a disease like neuroblastoma or medulloblastoma or any other pediatric cancer, it's defined based on the anatomical location of the disease or the type of tumor, but it's not really mechanistically defined. And when you take a treatment, often what you get is a very small subset of patients, maybe 20 or 30% respond. When you try to do drug development, advance a new treatment, it has to be the standard of care. And if it's only 20%, it won't get approved as a drug. So we lose a lot of drugs that don't get developed. In fact, a lot of adult drugs never even get tested here. And this bill that you just heard about is going to obviously change that. So we're very grateful for legislation like that. But nonetheless, we want to move towards a model that doesn't generate this type of data. If you go to the next slide, we can start to now probe the molecular features of a tumor. So genetic changes happen within the tumor cell that change the way it responds to a drug. We can measure those now and stratify patients into treatment groups. We call this information-based medicine. We can choose individual biomarkers and tailor the treatment against those specific genetic changes. That's what's been happening over the last 5 or so years in the field, that we've been getting a little better at classifying disease, not just based on anatomical features or histological features, but getting down to biomarkers. Where we really want to go, the destination is in the next slide, one back, is where we want to collect entire genomes. We want to look at the entire set of features that could be altered, measure them all, come up with exactly the tailored interpretation of what's wrong with that tumor, and choose from hundreds of therapeutic options and choose the one that's tailored, that's just right for that patient. And by doing so, greatly increase the chance that that child will respond. And we're starting with the greatest unmet need. We're starting with tumors that are going to be refractory to other treatments. We're starting with tumors where the patients have no other hope other than to find something new that is not a standard of care, that is tailored. The question is, how do we do that? How do we take billions of measurements and translate them into a therapeutic option? And the answer is, it's an integration of genomic technologies and computational technologies. This slide shows that we start with characterization of the genomic aberrations. So I won't talk about it today, but there's very sophisticated technologies that allow us to probe into the molecular features of a tumor. But then interpreting those requires a lot of computation you heard Dan von Hoff talk about taking a law library, putting it through a shredder, and then trying to realign it again. That requires a lot of computation. Currently, it takes, anybody else does it in the world, it takes about 7 days just in computing that information to get to the answer. With Dell's help, we've been able to reduce that down to a single day. And we just started the project in November. So already that we've been able to get a dramatic acceleration. And the reason that's important is you only have about 2 weeks to make that type of decision. You have to move fast, and these technologies do make a big difference. Then the other thing is we want to support a knowledge network. So the collaboration cloud allows us to not just store genomic information, but link it to therapeutic options and share it across distributed groups. So for example, this trial involves multiple groups. So we've got TGen represented up there. We also have the Van Andel Research Institute, where Dr. Scholler and her colleagues reside. We're also linked to the NCI, where some of the data is being generated and analyzed. And there's about 18 clinical sites that are distributed throughout the US. This network of collaborating clinical and research groups requires infrastructure to connect them. That's what the Dell Cloud does. That we have what we call the KIDS Cloud, KIDS standing for Knowledge Integration and Dynamic Systems. It connects all of those groups, the clinicians, scientists, and we're even developing portals for the families to empower them to participate in their own healthcare. All of this provides a collaborative environment and ecosystem that supports these types of trials. So just to walk you quickly through the workflow, it starts with the patient being recruited into the clinical trial. The patient's tumor is biopsied, a specimen is collected, DNA and RNA is isolated from the tumor and analyzed using the genomic technologies. We call that molecular profiling. And then Dell's technologies allows us to process that information, again, not in a week, but in a day. And then the processed information is presented as pathway and therapeutic options to the genomic tumor board. Again, these are a group of physicians. They may be geographically distributed. They're multidisciplinary teams of clinicians and scientists. They come together as a team to cure the kids. I mean, it takes a village to cure a kid. This is how we integrated a global village through IT technologies. The personal treatment plan then moves on, and the patient is treated, and we learn from that N of 1. And as we're going through, we're going to treat hundreds of kids. By the end of this trial, we should have about 700 iterations of learning of applying genomics to see what the outcome is. And with each iteration of treating a child and learning something, we hope to create a national model for how to advance this technology to improve iteratively and create a learning system to advance how we get better outcomes for these kids. So I'll switch it over now to Dr. Coffin, who's been the inspiration for this.
So I guess I want to start a little bit by telling you, why this is important to Dell. Why would a company like Dell really be interested in this? So we were looking for a way to we have the largest healthcare life sciences IT team in the world. We're about 13,000 people in our division. And we were looking for a way to use our foundation to really drive a huge change in clinical healthcare. And I called Jeff Trent up and said, Jeff, we've been talking about personalized medicine for the last 15 years. We've known each other for 15 years. We've been talking about it for 15 years now. And, now with this next generation of sequencing technology coming in and the next generation of high-performance computing, we're actually at a point where we can actually make clinically relevant decisions for the patient. So if he told you on the video that the Human Genome Project took 10 years and cost $3 billion. Just a couple of years ago, it would have cost millions of dollars, say 5 years ago, it would have cost millions of dollars and would have taken 6 or 9 months to do a full genome. A couple of years ago, it would have cost $1 million and it would have taken 9 months. And last week, we did one in 4 days and moved it to the tumor board. So now we're really clinically relevant. So that's a huge change in the way that we're approaching things. And what we really want to do is we want to give these patients the best chance of what they can do. If you know how drugs have been, I'm a pharmaceutical chemist by background, the way drugs were developed historically, a bunch of chemists sat in a lab and mixed stuff together and said, that looks like a drug. And then they tried it for different kinds of conditions. A drug like Lipitor, which is one of the most widespread drugs in the world, works in about 60% of patients. 20% of patients it has no efficacy at all, and another 20% they have serious side effects like liver side effects. What you want to do with personalized medicine is really target the drug to the tumor so that it only has the effect on the tumor and doesn't have all these extra side effects that you want. And that's why, things like PEDS, we haven't had much testing around drugs. It's really important that we start to test these drugs in children and make sure that we really understand, what the right doses are, how we treat them effectively. And this thing gives kids a really good chance. These kids with this disease, about 3% of them after they come out of remission live a year. So we want to get them on the drug as fast as possible. We get about 1 chance to get them on the drug because, these chemo cycles take a few months and they want the kids to have some time to rest in between cycles. And, you can probably do 1 or 2 cycles and you want to make sure you get them on the right drug now. So go to the next chart. So what we've done is we've installed one of the largest supercomputers in the world. It's about an 8 teraflop machine, if you want to get at it. That's 8 trillion operations per second, so a very, very large supercomputer. From what TGen had a large supercomputer before that took up a whole data center, essentially. We've actually increased the performance of their data center by 1,200%. So it's a huge increase in what they were doing. We've taken what they could do from days and weeks down to I think the last calculation, so the really stretch goal we were trying to get to is try to get this down to 1 day for the analysis, and last week we did it in 6 hours, I think. So, I mean, and that our stretch goal was 1 day. Now our stretch goal is we had to do the whole simulation, do the test on Friday, and when we come in on Monday, it's done. So that would be really exciting for us, so you can really, you know, we don't want to make these parents wait a long time to figure out what they're going to do with their kids either, so getting this done as quickly as possible is really important. We really think this is going to have a huge effect on the way, you know, you're going to treat kids. And you know, you said that we'd like this to be the model for pediatric cancer going forward. We think it is going to be the model. We're not just interested in just neuroblastoma. The reason we did this thing was we thought, you know, this is the toughest cancer there is. And if we can target this one and really go after it, it will start working for other cancers as we move forward. So we're really proud as a company to be part of this. Our team at Dell, you know, is very involved in this. We've got scientists that are helping to tune the codes. We've got scientists that are involved in helping to develop things like the portals and stuff like that for the patients. And we're really excited about the idea of, you know, being associated with this group because we think we're really going to change cancer. So thanks for your time today. Anybody have any questions for us?
Let me first say, applaud Dell and TGen for this effort. It's really fascinating. It's taking medicine to a whole other dimension. And
appreciate that.
And maybe if you could kind of simplify it for those of us who aren't doctors. But it's a very targeted approach.
Yeah.
And so you identify the particular gene that's causing the tumor, the cancer, and then how do you develop the drug that targets the...
Yeah, so we know there's about 150 cancer drugs out there right now, chemotherapy drugs, and we know what pathways are targeted. You know, we know when a tumor is formed, a certain pathway is activated, and we target that pathway with the drug. We know what drugs target which pathways, and so historically the way they've done it is they thought that, you know, all neuroblastomas were the same, so every doctor would try the same chemotherapies and they wouldn't work. And now we know, you know, that there's lots of different kinds of neuroblastoma. We can target to the individual pathway of the drug. You know, so we target the drug right to the pathway, and it kills the cancer from growing.
Without impacting the rest of the body.
That's the idea. I mean, there's still side effects of these drugs. When we really get it down to, we start developing these things individually for kids. You got to do it with the least number of side effects for the children too.
Because survivorship is always a big issue too. A lot of these survivors
get cancer later on.
They have issues their whole life. And can you tell us about any successes recently?
Sure. I mean, one of the biggest successes that we've seen in personalized medicine in pediatrics has been in neuroblastoma and medulloblastoma. We've seen, for example, durable responses in neuroblastoma. But just to answer your question about mutations, more specifically, there's a set of genes that fall into a pathway. A pathway simply means a set of biochemical steps that are in the sequence. And so it's not one gene, it's any one of these genes in this pathway. This pathway happens to be called the hedgehog signaling pathway. Right? There's a set of genes that are mutated within that pathway in certain cancer types. One of those cancer types happens to be medulloblastoma. And if there are mutations in this gene, it creates a vulnerability to inhibitors of that pathway. Now, these drugs would have never been tested in pediatric cancer, but it took Dan von Hoff to say, wait a minute, I know of a few indications, starting with basal cell carcinoma, but then also medulloblastoma, where we know that there are mutations in the pathway. We can predict that there's going to be a sensitivity. And when that was tried, we've seen miraculous responses. I mean, metastatic cancer just disappearing. We've seen the same thing happen in breast cancer and other cancer types. Just, you know, we can legitimately claim now that we have curative intent. Before, the best we can hope for with patients that have metastatic refractory cancer is palliative, which means we just, you know, we create some comfort for the patient until they pass.
And non-pediatric cancer, you know, adult cancer, we've seen it with companies like Amgen and Genentech have developed drugs for things like non-Hodgkin's lymphoma that, you know, if you have the right genotype, 97% of the time it eliminates the cancer. So we know we have models that really work. And it's exciting, you know, now that, you know, with this new genome technology that's coming in, we can actually do these tests in a real clinically relevant moment of time.
But you're focused on pediatric now, but this potentially applies to all kids.
Yeah, I mean, we're starting with the greatest unmet need, which is pediatrics. And the other dimension here, and I'll let Nancy talk a little bit more about it, is we really don't have access to the experimental therapeutics that we have access to in adult cancers. When you're looking at the genome, it opens up a whole universe of therapeutic options because you can discover things that it may be an experimental drug that you would want to bring in, but it's very difficult to bring those experimental therapeutics into pediatrics. And in fact, even if you see signal, it's very hard to get those approved for pediatric conditions. And of course, that's where we want to bring both the science and the technologies, but also with legislation together to change that. Do you want to add that?
Sure, with respect to the Creating Hope Act
Yeah.
in particular. Right, so the issue is that there's, you know, if an oncology drug is developed for an adult indication, which is how drugs are developed, and if the drug proves not to be effective for that adult indication, it's never tested in kids. And there are numerous cases now where pediatric cancer drug developers are hoping that unapproved drugs will be tested in kids because they have all sorts of evidence that these drugs can be very effective in kids. But the drugs go away. So we need TGen and Dell to identify new pathways that we can use to treat kids with terminal cancer. We're hoping that the Creating Hope Act creates financial incentives for pharmaceutical companies to stay in the game and to provide those drugs, those unapproved drugs, to pediatric researchers so that we can test them and get them to market when they're effective.
The other thing is we were in a panel this morning with the National Cancer Institute and ONC, and one of the things that kept coming up all day long was the restrictiveness of some of the regulatory compliance things around childhood cancer, you know, around things like HIPAA compliance, and not that these laws aren't very important for lots of reasons, but in pediatric cancer, I mean, she said it just a few minutes ago, they don't care about privacy, they just want their kids to be healthy.
But aren't the privacy restrictions the same for kids and for adults?
They are.
Patients are the same, it's just that as a patient population, we're unique in that we just don't care about privacy.
So we had a lot of conversations this morning about, you know, how we can work to kind of modify the IRB rules and HIPAA rules so that we can start to share this data in a much more efficient way for these childhood cancers where, you know, I mean, we had all the families of the National Medulloblastoma Neuroblastoma Consortium in Austin 2 weeks ago, and every parent said, we don't care. We just want, you can have anything you want from us if you can save our kid.
And even if your kid isn't safe, even if your kid is dying.
Yeah, parents are even as motivated. There was many parents there that are kids who died that were just as motivated.
Yeah, there are a lot of restrictions on experimental, you know, and then, like Texas Children's, I saw they took a child cell line, developed an adult, you know, drug, and they couldn't use that on the child because of all the restrictions. And I think you're right, the parents were just like,
we want to try it.
I mean, my child's going to die if you don't use it.
So one of the really terrific things, when we talk about cloud, a lot of people think about Google and Amazon and those types of clouds where people go and sell things, you know, and they're shopping and all sorts of things in the cloud. This is a dedicated healthcare cloud, so it is HIPAA compliant. It falls within the FDA regulations, and IRBs, and all of the. This is it's more secure than banking, right? So we absolutely do respect privacy and security and all of these things. We work with within all those confines. But what we're really trying to do in these conversations is try to shift the focus and say security is one thing, but we really have patients in front of us who desperately need us to share and communicate information across the networks. Thanks to Dell, we now have a dedicated healthcare ecosystem that does protect the data and enables it to be shared, so we can, and with some support in getting access to the experimental therapeutics, we could really make a big difference by stitching all these things together.
And that's something else that we bring to the table. I think that, you know, it's been very helpful for TGen is you know, because we're the largest healthcare IT services company in the world, we have more hospital and healthcare data in our data centers than anybody. So we know how to secure it probably better than any company in the industry. And we bring a lot of that expertise to make sure, you know, all this patient data is very secure. But we'd like to find ways to start to enable it to be able to do what the parents want us to be able to do. Yeah.
Exactly for those of us who don't quite understand the HIPAA and the IRB, how do they restrict your study and your work?
So from an IRB standpoint, if we generate data that's not...
Can you just tell everyone what IRB is, by the way?
Institutional Review Board. It's the board that decides how these clinical trials have to be done.
Within each
within each research organization
And the intent of the board is to protect patients
from doing something wrong to them.
From making decisions that are not in their own
Right, that's
favor,
right.
to make, you know, to be coerced into making decisions that are harmful to them.
That's right. Yeah, so there's very good reasons for having IRBs. We're not arguing that. Just in pediatric cancer, we believe that the kind of regulatory compliance you have to live by, which is, you know, if I do a genome sequence on a child and I want to use it in another trial, I'm not allowed to do that, even if the parents give me permission to do that. If I do a genome sequence on a child and the child wants to use it with another doctor, they're not allowed to use it because it's not done in a CLIA laboratory.
Right. So basically, these are the HIPAA protects privacy of patient information. What a lot of people don't know is that patients do have rights to receive data. So and the parents can request data and can themselves share the data. And what we want to do is step up to the responsibility of ensuring that we could support that technologically, support the privacy and security, you know, aspects, provide the tools that will allow all that, but also enable the sharing. Because as you saw, we're talking about 18 different institutions. Each one has their own institutional review board. We're talking about interoperability between hospital systems. Having a unifying ecosystem, the Dell cloud, allows us to navigate all of that complexity and create an interoperable system that allows data to be shared between the experts that can interpret it and extract meaningful value out of it and get the right drugs to the right patient.
And this collaboration allows us also to do it. Historically, the way they've done this is, you know, we did a genome test. We literally put it on a hard drive and shipped it from one site to the other and did the analysis. Now we can move the data in the cloud and do the analysis real time. So.
Can you talk a little bit about the work you're doing with, or what the connection is to NCI? Maybe just since, you know, it's congressional briefing, I'm kind of wondering, you know, for policymakers, what your technology and what you're doing, how that fits in with what government's doing.
Sure, I can start. So we're working with the leadership at NCI. So pediatric oncologists like Lee Hellman, for example, are taking a very active role. He was participating in the launch of the project. We were in New York announcing the Dell gift to pediatric cancer. And Lee was there to speak on behalf of the federal government. We're also integrating some of the clinical trials that we're going to be running are through the NCI as well. So we see working within the NCI critical because our destination, our vision, is to create a national model. And we think national leadership from the government, both on the legislative side and on the healthcare side at the NCI and the NIH, is critical to have that type of involvement. We're very lucky to have that participation.
To follow up on that, what are some of the impediments, you know, within the federal government that we could change that would help, you know, facilitate?
Well, I think we've seen a lot of support in breaking down barriers. Dr. Coffin just talked about the meeting we had this morning where there was the NCI and the ONC, the Office of the National Coordinator, got together. The Office of the National Coordinator supports information technologies in healthcare. So they are the #1 organization within the United States government that creates the regulatory environment for how to deploy healthcare IT. And we've gotten just tremendous support from ONC and NCI coming together and saying, how can we break down these barriers? We talked a little bit about data exchanges, we talked about patient privacy. This meeting this morning, it was incredible because you usually don't see the ONC and the NCI invite patient advocates to talk about what do you want to see as a patient advocate? How do you want us to create systems that will give in? So we're seeing that they're not just passively looking at this or creating barriers, they're actually partnering with us to break down all of those barriers.
And I think they see areas like oncology as a major force in, this idea of driving consumer IT health, using IT to really drive health. The people that care about it are the people that are sick. 80% of the population is fairly healthy, but people with chronic illness, the 20%, and then people with cancer are probably the highest value population for wanting to use IT to drive care.
So, and as a patient, I'll speak that I would like the right to waive my HIPAA privacy protections, which I do not have the right to do. And that impedes my ability to, it would impede my ability to get my son better treatment, or to support research that I wanted to support in this manner. And similarly, I want the right to review the genomic analysis that would have been undertaken in my son's tissue had he participated in this. Currently, under almost every IRB guideline, parents don't have that right. And that's a problem because that means that if they want to do a treatment after this treatment, they don't have the information to identify which medical team would be most appropriate.
Wouldn't that be part of the medical record?
No, because it's a clinical trial, it's not part of their medical record. So the challenge is, under HIPAA guidelines, the patient owns their data. Under IRB, the patient might own their data, but they can't see their data.
Wow. Well, those are two.
I think there's certainly there's certainly opportunity for legislative reform that could give patients many more rights, give doctors more rights, and patients and doctors should decide this together, and would result in better science.
That's good. Nobody else? Got our friend from Dell back there. You want to comment?
No, I just thank you, Congressman, for your leadership and hosting this panel, but also in dedication to the reforms that are needed to make this all possible.
And my thanks to Michael, who's really stepped up to the plate.
I'll be glad to pass it.
Well, and this is not just this is one of our signature giving programs now. This is not a one-time shot. We're going to continue to support this as part of the Dell Foundation.
Well, I'll be interested to follow your successes. I mean, how long have you been doing this?
We started in November.
So
just in the last month, we've taken the amount of time from hundreds of hours down to 6 hours. Imagine what we'll do in the next 6 months. No pressure.
We look forward to reading about the successes. Hopefully our bill will pass and
hopefully
before August, and that's going to help speed up things.
It's going to make a big difference.
Yeah.
We're very limited right now with therapeutic options. We can have to, it's incredible how much horsepower goes into generating the data and then interpreting it and analyzing it only to find out that we can't access the drugs that we need and getting the right incentive structure behind the pharmaceutical industry. And they want to help. They want to be able to help. I think we're really looking forward to this bill passing.
No, thanks for being here.
Thank you very much.